Welcome to Pavitra Laptop Care. See, in this schematic, almost all charging IC has AC in or AC detect, right? But usually it has given by voltage divider. The voltage has given through the voltage divider of these two resistors. See, it's R1 and this one is R2. R1 always positive side, it's a source 1, it's a first pin will be in source, and second resistor R2 resistor's destination should be ground. Then only we will consider it as a voltage divider. But the thing is, almost in all charging ICs, the AC in or AC detect pin has given by this voltage divider. But the main question is R2 is lesser than R1. See, R1 always it's greater, right? It's a 232K. But R2 is 49.9K. Why this kind of difference here? Why R2 always lesser than R1? Why it can't greater than R1? That is the question here. So let us discuss. Today's topic is voltage divider. Okay, I will take one more example. This is Dell Latitude series. Here also see R1 is greater than R2. R1 value is 316K and R2 value is 49.9K. Okay, one more Inspiron, Dell Inspiron I will take. So here also see AC detect. AC detect, R1 is 309K and R2 is, what is that, 47.2K. Here I have taken an Excel and the circuit, voltage divider circuit. The voltage has 19.5 volts. Here we need to identify voltage across R1 and R2. Okay, anyway, so as per the Ohm's law, the current will be constant in series circuit. Please don't forget it. I will repeat. The current will be constant in series circuit. Now we can apply all kind of possibilities, R1 and R2. R2 will be greater than R1. What will be the case? What will be the output? In case R1 is lesser than R2, then what will be the result? In case of equal, what will be the result? All possibilities we will check. Now what I am going to say is now I will take voltage, total voltage 19.5. Now V1 we don't know, V2 we don't know, means V1 is the voltage across R1, V2 is voltage across R2. Here V1 have given, but actually the V1 is this one. Okay, please consider this one. So now total of resistor. Now for example, what I am going to do is I will take R1 as a 1K and R2 as a 1K. Equal resistor we will take. Then 1K means it's 1000. Okay. In Excel I am taking it as 1000 ohms. It means it's 1K ohms. Okay. Now R total, what will be there, is equal to R1 plus R2. Now what will be the current? First we need to identify the current in a circuit, right? So formula is V is equal to IR for voltage. Now current, right? I is equal to V by R. Now we know the voltage. Total voltage is 19.5 and total resistor is 2000, means 2K ohms. Now is equal to, we apply the formula I is equal to V by R. It means 19.5 divided by, instead of this, we will select this one. This is the voltage divided by total resistor. This is the formula. See, the current is 0.00975. Now easily we can check that V1 and V2. V1 across R1 and V2 across R2. How? V is equal to I into R1. In case of V2, V2 is equal to I into R2. Okay. Now the formula we can apply it. See, I, this one, right? This one into what? R1. Correct. So now what voltage it has come? 9.75. Now V2 we'll apply the formula I into R2. Here also 9.75, correct. The voltage across R1 and R2 will be the equal because R1 is 1K and R2 also 1K. In that case, it will be continuously equal voltage you will get. Okay, in circuit we can check. See, I'll apply the formula. Here is 1K R1 and R2 1K. See, in practically what voltage across this voltage divider, what voltage we will get, we will check. Now as per this, V1 is 9.75 and V2 is 9.75. V2 means this is the one is the voltage divider voltage. Now we will check in the multimeter. See, 9.75 we got. Okay, in case R2 is greater than R1, then what will be the result? See, I will make it as 2K. 2K I made. See, current is less. It was 9 point something, right? So 9 something was there. Here total resistance is 3000 and voltage across V2 is greater than V1. V1 was 9.75 but it reduced. Okay, practically we will check in case R2 is 2K. See, let us check. See, 13 volts. 13 volts. It means in case R2 is greater than R1, we will get more voltage than R1. See, here is the 6.5 volts in R1 and in R2 the voltage divider case 13 volts we got. Okay, I do one thing. 2K I will put R1 and 1K I will put R2. Then what will be the result? See, here R1 is the 2000. 1 minute. Here R1 is the 2000 and R2 is 1000. See, current will be the same because here just vice versa, it got interchange. R1 is greater than R2 now. Before it was less, right? So now let us check the voltage divider across R2. Now what I'm going to do is, this one is 1K and this one R1 is 2K. 2K. So now what is the result? 6.5. See, here V2 is 6.5. Now you got my point, right? When the voltage, when the resistor are equal, R1 and R2 are equal, the exact half of the main voltage, the total voltage will be there, no? Half of the main total voltage you will get in voltage divider case. In case R1 is greater than R2, then you will get, what is that? R1 is greater than R2. What you will get? Now its R1 is greater than R2. Now it's a Vin is 13 volts and voltage across R2 is 6.5 volts. It means in case R2 is lesser than R1, then you will get lesser voltage across this voltage divider. Got my point? Lesser voltage, instead of 9.5 we are getting 9.7 was there, right? So 9.75 volts was there when both are equal. Now you got 6.5 volts. It's a lesser than R1. In case both are equal, so both equal voltage you will get. In case R2 is greater than R1, your voltage divider will be more than R1. It means 13 volts you will get in R2. Right. So as per this, the voltage divider formula has taken. Now you come to know when R2 is lesser than R1, we can get less voltage across this point. Okay, this is the concept. always R2 should be lesser than R1, then you will get lesser voltage. This is the answer. Now what we will do, we'll check the schematic. As per the schematic, we'll put the voltages and resistors, and what will be the result we will get, that we will check. In this voltage divider, 232K is R1 and 49.9K is R2. See here, 232K means 232K. Okay, this one is 49.9, 49,900. So then this is the current, and the voltage across V1 is 16 point something, and voltage across V2 is 3.45. Can we check once? See here, I will change R1 as 232K, 232K and 232K, and R2 is 49.9K. Now what will be the result? See, 3.45. Exactly 3.45 we will get. Now second schematic. As per the second schematic, what will be the result? See, this one is latitude series. R1 is 316K and R2 is 49.9K. 316 only changes. 316K. What is the voltage across V2? 2.65. Let us check in case of 316. Okay, now you check 2.659. What is the voltage here? 2.659. Correct. So second, as per the second schematic also, we got if R1 is greater than R2, we will get lesser voltage here. And final schematic also we will check. See, in this here 309K and here 47.2K. R1 is 309K. R2 is 47.2K. Okay. Now what is the result here? 2.58. So now we will apply the formula here. What is that? 309K. 309K and R2 is 47.2K. 7.2K. Now we will check the result. See, 2.584, 2.584. The answer is correct. Like this, the voltage divider will work. Now you got my point, right? So that's the reason R2 always should be lesser than R1, because the charging IC is required minimum voltage. It means it's a 2.5 to 3.3 or little bit here and there. So that's the reason we'll calculate and they will put the voltage divider value, the resistance value. So now if you have any questions, so put it in the comment box. If not yet subscribed, please subscribe my channel. Thank you very much.